Hello again, algebra students. This is Mr. D'Amico coming at you with another lesson in algebra. Today's lesson involves piecewise functions. I would like you to write down our goal for the lesson on your paper. By the end of this lesson, you should be able to graph a piecewise function on the coordinate plane, and then you'll be able to state the domain and range of the piecewise function as well, like we have been doing the last few days. Here's what a piecewise function looks like. We call it a piecewise function because the graph will be in different pieces. They won't be connected, and you could have as little as two pieces, like our equation will have here, our function, or you could have three pieces or four pieces, or literally as many as you want depending on what the function says. We read this as f of x is equal to x if x is greater than or equal to 0, as well as f of x is equal to 1 if x is less than 0. So let's start with the first part, the first piece, f of x equals x if x is greater than or equal to 0. So let's make a table, and we need to decide what domain values we are going to have for our table. Well, I'd like you to look and see that the greater than or equal to 0 part, that's going to help us determine our domain values. We want to remember that greater than or equal to, when we're graphing, means that since it's equal to, it includes that number 0, so that would be represented by a closed circle, as you can see right there. And since we're going to be greater than or equal to 0, we can start with our first domain is 0, and then we can pick two numbers that are greater than 0. I like to pick the consecutive numbers, so I start with 0, and then my next two greater consecutive numbers would be 1 and 2. Okay, now it's time to find our range. Well, if f of x equals x, that means whatever our domain is will also equal our range. So if the domain is 0, our range would be 0. If our domain is 1, our range would be 1. And finally, if our domain is 2, our range would be 2 in that part of the function. So now we're going to graph. We're going to put a closed circle on 0, 0. And then we're going to graph the other 2 points. We're going to graph 1, 1. And we're going to graph 2, 2. Next, it's time to draw our line from 0, 0, going through 1, 1, and 2, 2, and then increasing at the same rate. So that's the first piece of the piecewise function. Now we turn to the second part, the second piece. F of x equals 1 if x is less than 0. So we go ahead and make our table. And this time we're going to look at the part that says less than 0. Now this isn't less than or equal to, it's just less than. If we have less than, we represent that part by an open circle, not a closed circle like we did on the other part, which is in red. And then we're still going to choose 0. I know it says less than 0, but we're still going to choose 0. We'll be okay with the open circle there. We just won't fill that in on the graph, and you'll see that in a second. So then we want to pick two values that are less than 0. We will choose -1 and -2. And then for this function, f of x equals 1, since there is no x value, the range is constantly 1. So all of our y, all of our range values will be 1, and then we're going to graph it. So this time 0, 1 will not get a dot, will not get a closed circle, it'll have an open circle on 0, 1, and then we can graph the points -1, 1 and -2, 1, and since those 2 points are going to be on a horizontal line, you can see there that the graph of the horizontal line will go through there. So if we look carefully over here, that's where the point -1, 1 would go. That's where the point -2, 1 would go. And then you can see we just connect them by drawing that horizontal line. And it looks like that. There's the two different pieces. You have one in green and you have one in red. Now it's time to write our domain and range, which is the second part of our goal. Recall that if you are looking for the domain, you need to look at the graph from left to right, because the domain is our x values, so you need to look at the graph from left to right. So the farthest left that this graph goes, again, if we look up here, this keeps going on and on and on towards negative infinity. And then as we look again, the graph continues to the right, continues to the right. It looks like it stops and does not include 0 for the domain, but it drops down here, and since that circle is filled in, 0 is included in this piecewise function. It just is not on the green line. It jumps down to the red line. So 0 is defined for this function, and it continues on and on to the right forever and ever and ever. So even though you jump from the green line to the red line, it never skips. In other words, there's never any x values that this function is undefined for or not included. So it is continuous from the standpoint that it does go from left to right. You do jump from the green to the red line, but there are no values that are skipped. So that just means that the domain goes from negative infinity to positive infinity. Recall that when we're looking for the range, we must look at the graph from bottom to top. So what's the lowest that this graph goes? Well, let's look again. It doesn't get any lower than this right here, so that would be 0 for the range, is the smallest that it could be. And then it continues on forever, and it keeps going up and up and up. So the lowest that this graph could be would be 0. It gets a bracket because it includes 0. It's a closed circle there. And then it continues on to positive infinity. Okay, our second one. We have f of x equals x plus 1 if x is less than 1. So let's go ahead and make a table for that. And let's focus on the part that says x is less than 1. So that's going to have an open circle because it's less than, not less than or equal to. So we'll start with 1. Then we want two numbers that are less than 1. How about 0 and negative 1? And now we substitute in. So this time we substitute in x. So we have 1 plus 1. Our range would be 2. We have 0 plus 1, which means our range is 1. Negative 1 plus 1, which means our range is 0. Now it's time to graph. We put an open circle on 1, 2, because again, it's not including that point. And then we can put just dots on 0, 1, and negative 1, 0. And then we can go ahead and draw the line that looks like that. Our second piece in our piecewise function, f of x equals x plus 3 if x is greater than or equal to 1. Go ahead and make our table for that. This time it says this only works if x is greater than or equal to 1, so we're going to represent that by a closed circle, which means we want to include 1, and then we're also going to put 2 and 3 there because those are greater than or equal to 1. Now we can substitute our domain in. 1 plus 3 is 4. 2 plus 3 is 5, and finally 3 plus 3 is 6. So let's put a closed circle on 1, 4. Let's put another dot on 2, 5, and 3, 6, and we'll go ahead and we'll draw that line there. Okay, so there's our piecewise function. Let's do the second part of our goal, which is domain and range. Okay, again, how low does this graph go? So we start looking at it and we say, okay, well, it keeps going to the left. For domain, we look at it from left to right. It goes to the left, and it just keeps continuing on and on and on. So that would start at negative infinity. And then if we come back here, keeps going right, keeps going right, keeps going right. It gets to 1. Now, it doesn't include 1 here, but again, if we jump up to the green line, it does include 1 there. So it doesn't skip any numbers in the domain, and it continues to the right forever. So that would be negative infinity to positive infinity. Let's look at the range. So now the range, we have this graph keeps going down, down, and that would start at negative infinity. And then you can see that it stops here at 2. Okay, it doesn't include 2, and then there is definitely a space or a gap. So we want to start with 2, but it would get a parenthesis because it doesn't include 2. And from here, it jumps all the way up to 4, and then it continues up to positive infinity. So 4, we get a bracket because it includes 4, and then it goes on to positive infinity. Remember, when we have a gap or a space, like you can see right here, we use what's called the U for union. So that means the range would be all the solutions from negative infinity to 2, not including 2 because it's an open circle, and then it would jump up to 4 and go on to infinity. That is piecewise functions. Thank you for watching, and I hope you don't get any of those equations that you see there on the board, but have a great night, and we'll see you all in class tomorrow.